Everyone. So our topic for today is about database concepts. One of the ways to organize data is with the use of database. A database may or may not be inside a computer, an office filing cabinet full of letters, memos, reports, and other documents is a valuable database because database is a collection of organized data, information, and records. So this will be the lesson objectives. In this lesson, you will learn basic database concepts and learn how databases are used on the World Wide Web. Upon completion of this lesson, you should be able to describe the nature of data, understand the purpose and function of relational databases, describe database elements, understand database relationships, understand how to read a database schema, and describe the uses of databases on the web. Now, so what is data and database? Data are pieces of information. Data can be measured, collected, analyzed, and reported. Data can exist in many forms, as a phone number scribbled on a scrap of paper, as a course listing in a catalog, or a list of test scores on a grade report. Data is distinct from a container in which it is stored. Data can be stored on a flash drive, or in a book, or in remote storage location on Google Drive, OneDrive, or Dropbox. And data can also be stored in a spreadsheet or a database. But these containers are not data and their contents are data. So, what is a database? Although many people become uncomfortable at the thought of working with a database, a database is really nothing more than an organized collection of information. The basic function of a database is to store data. If the database is well organized, retrieving the data you want is easy, and you can then generate reports or lists and analyze the data in ways that are meaningful. Spreadsheet databases. Actually, you can create simple databases in Excel. A database is Excel, and Excel is a single table that cannot include any blank rows or columns. This type of database is sufficient for storing relatively small amounts of simple data. But even though you can perform complex calculations on the data in an Excel table, a single table cannot represent or handle complex data relationship. Relational Database Management System or RDBMS. A database application, on the other hand, is designed to handle complex relationships between various items of data and is correctly referred to as Relational Database Management System or RDBMS. Many relational database applications are available on the market. At present, we have Oracle, SQL Server, MySQL, PostgreSQL, Sybase, IBM DB2, and Microsoft Access are just a few. These programs offer various features and interfaces, but all of them access stored data in a standard manner through Structured Query Language or SQL. A structured query language is the standard language used to create and work with databases. Once a database has been created, SQL is also used to retrieve and manipulate the data. An interaction among a user, program, and database takes place through the use of SQL. Even though various RDBMS applications provide their own user interface, SQL is used to create and manage both the database elements themselves and their data. Connectivity standards and API. Generally speaking, database is not portable from one RDBMS to another, but different RDBMS can interoperate using one of the following application programming interface standards. We had Open Database Connectivity or ODBC. For an IT practitioner, no, we need to be more familiar with this, no? A standard programming interface for accessing a number of different databases, including Access, DB2, SQL Server, and MySQL. Another one is Java Database Connectivity or the JDBC. That is also a standard programming interface for accessing Oracle databases which run on the Java platform. An application programming interface or API is a set of programming building blocks that specify how software components should interact. There are APIs for operating systems, applications, and website. These interfaces make it possible to connect databases to web pages. Web designers can then use server-side programming language to build web pages on the fly based on current database content. The multiple and related tables, unlike spreadsheet databases which store all the information in a single table, relational databases store data in multiple tables which are related to one another. Let's consider a database that tracks activities for a gardening supply company. There might be a table that contains customer information, a table that contains order information, a table that contains detailed information for each order, and a table that contains product information. Because the data stored in each table is related to data in the other tables of the database, a complete set of information can be retrieved. For example, you could retrieve the complete information for a particular order. So, for example, displaying the order number, first name, last name, order date. And it's also display the item, quantity, description, price, and the line total. So the data, as I mentioned, is, of course, a piece of information. And the database is organized collection of an information. Now, as I mentioned earlier, no, Microsoft Access is a database management system or DBMS from Microsoft that combines the relational Microsoft Jet database engine with a graphical user interface and software development tools. The database tables. In a database, the data is stored in tables. So, the data in a table is organized into a series of rows and columns. The following figure shows a portion of a typical Access database table containing product information for items sold by a garden supply shop. In database, each row in the table can be referred to as a row or a record. In the table shown in the preceding figure, each record contains information about a different product sold by a garden supply shop. Each column in a table can be referred to as a column, a field, or an attribute. Each field contains a different type of information such as item number, description, unit price, and so on for each product. Table metadata. In a spreadsheet, you can create a table simply by opening a blank workbook and typing. In fact, you can enter any type of text or value into any cell or at will. A database table, however, is a different animal. The structure of a database table must be explicitly defined before you can enter any data. A table's structural definition includes items such as, of course, the name of each field or column in the table, the name of each field, of course, as I mentioned, as a column, and the data type of each field or the column. Actually, the data type determines what type of data the field can contain. Each field can contain only one type of data. If the field is designed to accept text data, only text can be added to the field. If you enter a number into a text field, that number is treated as text, which means that you cannot perform any calculation on such numbers. If you define a field to accept numeric data, you cannot enter text into that field. The size of each field. The size determines the range of numeric or date values that can be entered or determines the maximum number of characters that can be entered in a text field. As what we have here, the figures show two views of the same table in Microsoft Access. The left portion shows the defined structure of the table, and the right portion shows the data stored in the defined table structure. Without this clearly defined structure, the data itself is simply a collection of items presented out of context and without relation to other things. The database table's defined structure helps the user to make sense out of the data and to understand what the data is. Because the defined structure of the database table describes the data it holds, the structure is considered metadata. Because metadata is simply data that describe other data. We need to take note that you may have worked with metadata before. Computer files have metadata associated with them in the form of file properties, which you can use to locate a specific document or a particular image or a specific version of a program. If you have ever viewed a file's properties in Windows or added tags to an image on a social media site, you have worked with metadata. The table metadata, that is table structure actually, can be represented by a simple layout called a table schema, which lists the name of the table and the names of each field in the table. Database designers create table schemas while they are planning a database. Once tables are created, many database products can render table schemas to give the database designer an overview of the tables in the database. So the following schema is generated in Microsoft Access. Like for products, for example, item ID, description, unit price, quantity stock, and vendor ID. Another important thing that we need always to be considered is the primary key. A primary key is a field or a combination of fields that uniquely identifies each record stored in a table. No two records in a table may be exact duplicates. However, two records may have identical data other than the primary key. The primary key, therefore, must be unique and it cannot contain a null value. In a database, null is equivalent to unknown or null is not the same thing as 0. Assigning a primary key prevents the entry of any record that contains duplicate or null values in the primary key field. When you add a record to a table for which a primary key has been assigned, the RDBMS checks to make sure you have included a value in the primary key field and that the value you enter does not already exist in the primary key or primary key field of any other record in the table. When you sketch a table schema, you can indicate the primary key by adding the notation PK to the right of the field name or by underlining the primary key field. In Microsoft Access, uses a key icon to the left of the field name to denote a primary key. Again, we need to understand that a primary key that is comprised of a combination of fields is called a composite key. The figure at the right side shows schemas for two tables. The products table has a single field primary key, the item ID field, and the order items table has a composite primary key, the order ID field, plus the line item field. In selecting a primary key can be a challenge. Many times, a simple numerical value that increments automatically is added to a table to serve as the primary key. However, sometimes, a table already includes a field that is a natural choice for use as a primary key. For example, in a table that tracks books sales, an ISBN field would be a good choice. A primary key should be a value that will never change or be a value that is extremely unlikely to be null. A good choice for primary keys include unique identifiers issued by an organization such as employee ID number or student ID number or an ID field. Poor choices for primary keys include people's names as they are likely to be duplicated and they sometimes change. And social security numbers, not everyone has one. And business do not like to store them because of the potential liability if they are lost or stolen. So, as what we have here, you may consider this table shown at the upper part. As we notice that there are two entries for a person named Dennis Henderson. If you look only at the F name and L name fields, the records appear to be duplicates. However, if you look at this field in the address field, you can see that the records are not duplicates. It would be possible to use the combination F name plus L name plus address as a composite primary key. It would also be possible to use the zip field as a primary key because right now each entry for a zip code is unique. Neither or of this is really a good solution. If we use the zip field as a primary key, we would be unable to add a record for another person living in the same zip code as any person already listed in the table. Using the combination F-name plus L-name plus address field is not a good solution either because people move and the primary key for a people who relocates would change. A better solution for this table would be to add an ID field as shown in the following figure. So when you use an ID field as a primary key, you can manually enter the ID number or you can elect to have the RDBMS create ID numbers automatically. In Microsoft Access, you can create ID numbers automatically by setting the ID field, data type property to auto number. A field with an auto number data type is automatically updated with a unique sequential number whenever a record is added to the table, and the value in an auto number field cannot be deleted or changed. In this exercise, you will examine table schemas and select an appropriate primary key for each table. So, what would be a good primary key for the student table? And what would be a good primary key for the movies table? Table relationships or foreign keys. The data in a relational database is stored in multiple tables. So naturally, there needs to be a way to bring the data from those separate tables together in a meaningful way. This is accomplished through the defining of table relationships. Table relationships are defined through the creation and association of foreign keys. A foreign key is a column or combination of columns in a table that references the primary key in another table. For example, consider the simple scenario of customers in orders. Suppose we have a customer table and an orders table. As what we have here in our example, a one-to-many relationship exists naturally between customers in orders. One customer may place 0, one or many orders, but an order can be placed by only one customer. The way the tables are configured right now, there is no way to keep track of which customer places an order. And we want to be able to trace an order back to the customer who placed in it. The best way to keep track of each customer places an order is to create a field that is common in both tables. In the orders table, this common field will become a foreign key when we create a relationship between the tables. And here we see a revised design of the orders table at the bottom. It now includes a field named customer ID, and this is the common field. It exists in both tables. In the customer table, the customer ID field is the primary key, denoted by PK in the diagram. In the order table, the customer ID field will become the foreign key when a relationship is created between the two tables. The foreign key is denoted by FK in the diagram. One of the common fields is added to an orders tables, and you can create a relationship between the two tables. In Access, you can open a special window called the relationship window and drag the primary key field from the customer table onto the common field in the order table, and Access will create the relationship. Behind the scene, SQL adds a constraint that will not allow you to add a record to the orders table if that value in the foreign key fields does not match a value in the primary key field of a record in the customer table. It is at this point that the customer ID field in the orders table become a foreign key. That is, when you create a record for a new order, the value that you enter in the customer ID field in the orders table must reference a record that already exists in the customer table. You cannot create an order for a customer who does not exist. The following figure shows the data in the customers table in the orders table. In the customers table, the customer ID field is the primary key and it uniquely identifies each customers. However, in the orders table, the customer ID field is a foreign key and it is used to refer to a specific customer in the customers table. We need to take note that the primary key to which a foreign key maps is also known as a parent key. The line draw between two tables represent the relationship between the two tables. We need to take note that the line is drawn connecting the common fields. Often, the common fields have the same field name, but that is not a requirement. However, common fields must have the same data types. When you create relationship between tables, you can view and work with data stored in multiple tables. For example, you can view customer and order information contained into different tables to see which customer placed a particular order. The related tables shown in the figure indicate that in order 1, customer number 1012 or Helen Anderson placed an order on February 19. Relationship types. There are three types of relationship that can be established between tables. Type number 1 is one-to-one. A relationship in which its record in table A can have only one matching record in table B, and vice versa. This type of relationship is not very common. Number 2 type is one-to-many. A relationship in which a record in table A can have many matching records in table B, but a record in table B has only one matching record in table B. The relationship is established between the primary key in table A and the foreign key in table B. Many-to-many. A relationship in which one record in table A or table B can be related to many matching records in the other table. So for example, suppose a database contains data about students and classes. Each student can be enrolled in several classes, and each class can have many students. This is a many-to-many relationship. Relational databases cannot directly handle many-to-many relationship, and this must be replaced by multiple one-to-many relationship. The database metadata or the database schema. A while ago or earlier, you examined table metadata. However, there is also metadata for the entire database, the database schema. The database schema represents a logical view of the entire database. It defines how the data is organized and how the tables within the database are related to one another. You can represent relationship in database schema by drawing lines between the key fields in the related tables. The primary key of each table should be denoted either by an underlined field name or a representative icon. You represent the one side of a one-to-many relationship by drawing a 1 beside the parent key, and you represent the many side of a one-to-many relationship by drawing an infinity symbol beside the foreign key. So, the following figure shows a schema, actually that is generated in Microsoft Access for a database with 4 tables. So, we have here the books, authors, and publishers. The database schema in a preceding figure described the following relationships. There is a one-to-many relationship between the publishers table and the books table based on the publisher's ID field. There is a one-to-many relationship between the books table and the author books table. It is based on the book ID field. And there is one-to-many relationship between the author's table and the author books table. It is based on the author field or author ID field. We notice that the author books table is related to both the books table and the author's table. And these two one-to-many relationships support the many-to-many relationship between books and authors. One author can write many books, and a book can have many authors. A database queries. You use queries to view specific data in one or more database tables. A query asks a questions of a table, such as which customers live in the Philippines, and select records from the table which answer the questions. The selected records are displayed in a result set. So, the queries work by checking table fields for entries that meet the criteria that you specify. The criteria can be strings of text, dates, or a number or range of numbers that you enter. The query examines each record in the table to determine if particular values in the record match the query criteria. If a record meets the criteria, then it is displayed in the result set. The result set of DynaSet or dynamic subset is not a static snapshot of records, but a dynamic changing subset of records. As changes are made to a table, the results of a query will change accordingly to reflect the current content of the table. So for example, suppose you run a query on a table containing 100 records, generating results with 30 records. If you then added another 20 records to the table and then run the query again, the results will also include any of the newly added records that meet the selection criteria specified in that query. If only 2 records of the additional 20 met the criteria, then the query would generate 32 records, even though the same query generated only 30 records a few minutes ago. If you are working in a database, you can use a query to answer a simple question. View only specific table fields, perform calculations, combine data from different tables, or to add, change, or delete that table data. The database forms. Forms are tools that aid data entry and help users understand what they need to do. They are user-friendly interfaces designed to help users enter specific data without becoming distracted or confused by other data that may be stored in a table. You can think of a form as a window into the data. Instead of allowing or forcing user to view all the fields in a table, a form displays just that the record that is necessary for performing a given task. So we have here a figure. The first show a data entry from created in Access. A user can enter data about an order using the form. Transparent to the user, the data entered through the form is added to 4 database tables which are shown in the next figure. So where are databases used? After this little worldwide tour, you may have already decided that you have had your fill of databases. They can seem cumbersome and confusing, especially at first, and you may think you will never have a reason to use a database. However, chances are good that you interact with databases all the time and don't even know it. In short, databases are used almost everywhere you look. Medical records, flight reservations, legal pleadings, online orders, Pinterest, Twitter, Facebook, and WordPress posts are all stored in databases. Databases and website. The web is replete with databases because databases are extremely flexible and scalable. They can store millions and millions of records, and they can present data in almost any form you need. Online store, you just try to think of Amazon or Shopee and many more. Display thousands and thousands of items and allow you to sort and filter the items on the page by price, by vendor, or size or color. The options are almost endless. All the data that populates that page of choices is stored in a database. but you never have to see the database itself. Why? Because it is an easy thing for a web designer to design a web page that connects to the database on the back end where the website visitors never sees it. Visitors simply enjoy a normal web experience while interacting with database all the while. We have static and dynamic web pages. Actually, these are the two basic types of web pages. When we say static, these types of pages display contents that does not change unless the web page developer edits what is on the page. These are the normal pages you build with HTML, XHTML. Anytime you visit a static web page, your computer sends a request to the server, and the server sends the web page to you over the internet. The page is stored on the web server and served in the same condition every time a request is received until the web developer edits it. While the dynamic page, these pages change every time they are loaded in the browser window. They change their content based on user actions. For example, if you are viewing digital cameras on the Best Buy website and you apply filter because you want to see only GoPro cameras, the page is automatically rebuilt, regenerated, and resent to your browser. Often these pages are built using languages such as Active Server pages, Java Server pages, CGI, or Perl. The database-driven web pages. Many dynamic web pages are database-driven. The web page is connected to a database through programming, and it pulls information from the database and insert that information into the web page each time the page is loaded. As information is stored in the database changes, the web page connected to the database also changes to reflect the new data. Actually, it's automatically changed, no? Banking website use database-driven pages. You log in and view your account, and the web page connect to a database where all your account information is stored. The page always shown the most current information because it is connected to the database, a real-time database. So, try to consider this image as a website page featuring Martin guitars. So, as you scroll through a click option on the left side of the page, you are specifying certain criteria conditions that you want the guitars to meet. For example, you may want to see only those guitars which fall into a certain price range. Each time you click a button or check a box on the left side of the page, your browser sends that information to the web server along with a request for an updated web page. The server generates a new page and send it back to your browser. How I use queries on the web. It is likely that you use queries all the time while you are on the World Wide Web. Have you searched for a particular item in an online store? Have you searched to see if a particular check has cleared your account in your online banking website? Have you searched for credit card changes in an online account? Anytime you click in a website search box and specify an item to look for, you are specifying criteria for a query that is executed on a database. Anytime you specify that you want to see a list of credit card purchases that were made during a specific time frame, you are specifying criteria for a database query. The result that you see on the web page are the result of the query. Have I used forms on the web? You probably already guessed the answer. Anytime you set up a profile for an account, enter an email address for a newsletter, or enter payment information for an online purchase, you have likely used a web form which is linked to a database. Fields on the forms are tied to fields in a table in database on the back end. So, this will be my references. Of course, the CCI Learning Solutions, 2016, page 353 to 369. Abante M, An Introduction to a Database Using MS Access by Unlimited Books Incorporated. Abante M et al., 2019, MySQL, Unlimited Books Incorporated. Okay, before I end, in this lesson, you learn basic database concepts and learn how databases are used on a World Wide Web. You should now be able to describe the nature of data, understand the purpose and function of relational databases, describe database elements, understand database relationship, that is one to many, many to many, one is to many. Understand how to read a database schema, and describe the uses of databases on the web. And that's it. Good luck. Enjoy the rest of the semester.